Okay, allow me to share my screen. Okay, I have one. Okay, so this is our ninth topic for first order differential equations. So this being the ninth, so we'll have this labeled as ninth. So this is first order differential equations with coefficients linear in two variables. Or it could be even only having one variable as long as the coefficients are linear. Okay, so let me give you an example of what are these particular differential equations. Okay, so you can have here 2x plus y minus 1 dx plus, let's say, x minus y plus 2 dy equal to 0. Now, what are the coefficients that are being referred to in here? So the coefficients of your DE are this, the 2x plus y minus 1 and the x minus y plus 2. These are the coefficients. They are said to be linear because they resemble the equation of a line. At the same time, the variables have only exponents equal to 1. If the variables that you are seeing here in the coefficients have exponents other than 1, then the said equation is non-linear. If you see functions as well in the coefficients, that makes it as well non-linear unless there's another way of you to convert those functions into a variable using the method of substitution. But nonetheless, to make things simpler, we say a first order differential equation has coefficient linear in two variables or even one variable if it has only the variables x and y, or it has only the variables present in the coefficients together with the constants. Now let's see how we're going to solve. We're going to find the solution of this first order differential equation, which is said to having coefficient linear in two variables. What you're going to do first, class, is to determine the intersection, the coordinates of the point of intersection of these lines here represented in the coefficients of your differential equation. So what do I mean? So we copy our coefficients. You have 2x plus y minus 1. We equate this to 0. Then we have that x minus y plus 2. And we equate that as well to 0. Then we find the point of intersection of these two lines using the methods that were discussed to you in algebra. You can have substitution, you can have elimination. It depends on what particular method you will use, as long as the goal is you'll be able to find the coordinates of their point of intersection. Now, if we add these two equations, we get to cancel right away the y. Okay, you get to cancel right away the y. So you have 3x. And then you add this, you have 1 equal to 0. So 3x is equal to negative 1, and we say x is equal to negative 1/3. Okay? Now, then you go back to any of the equations that you have here and substitute the negative 1/3 to find the y. So let's say we'll use the second one because it's simpler. So you have x minus y plus 2 equal to 0. And you substitute this one, negative 1/3 minus y plus 2 equal to 0. If I will transfer the y in here, that makes it positive. And I have 1/3 negative plus 2, so that would be 1 and 2/3 is equal to y. I'll make this as a fraction, an improper fraction. So I'll have this 5 plus 2, so that would be 5/3. Okay, you have that, you have that as equal to y. So you already know the coordinates of the points of intersection. So the coordinates are negative 1/3 and 5/3. Okay, now what's the use of this coordinates of the point of intersection? You're going to use two equations here. Okay, you will have x is equal to b plus h, and you'll have y is equal to u plus, let's say, k. Actually, class, the letters H and K are just arbitrary, in the same way that the V and the U here are just arbitrary. You just choose any letter that you like to represent the four letters that you are seeing here. But nonetheless, the H here corresponds to the X coordinate of the point of intersection, and that is, in that case, negative 1/3. So that's the purpose of the coordinates there. And the k is the y coordinate. And that is your 5/3. 5/3. Okay? As to the question, is this really the equation that you're going to substitute your uh, coordinates of the points of intersection? The answer is yes. You just may just change the letters here, but this is really the equation. The purpose is you will replace the x and y variables that you have in the original differential equation by these new variables b and u. So now it follows from here that x is equal to b minus 1/3 and y is equal to u plus 5/3. Now, just like in the method of substitution, whenever you substitute a new variable for a set of expression, you're going to differentiate that equation. So meaning you have this time two equations to differentiate. So differentiating x equal to v minus 1/3 would yield dx equal to dv. Derivative of a constant is 0, and dy equal to du. Because the derivative of 5/3 is also 0. Now, what's the purpose of this? What's the purpose of these four equations that we have now? Okay, I will just use a different color. So what's the purpose of this? This one, and this. The x should be replaced by this, the y should be replaced by this, the dx should be replaced by this, and the dy should be replaced by this. Meaning your original DE, this one, will now be changed to a new DE which has variables b and u. Okay? So now we go back to our DE. So we have 2x, sorry, plus y minus 1. So I'll just copy it so you will see the substitution. 2x plus y minus 1 dx plus x minus y plus 2. Okay, so I copied the original DE. Let me just check 2x plus y minus 1. Okay, that's it. So we have copied it correctly. Then we will replace the xy, dx, and dy by these expressions in here. So you will have 2 times b minus 1/3 plus u plus 5/3 minus 1. The dx will be dv plus you'll have x again. You'll have b minus 1/3 minus the y, which is u minus 5/3. So I place minus for this one because it's a minus here. It's a minus in here for the y. So that would be minus this expression. So it will all be minus. Then you have plus 2 dy. This still is equated to 0. Next thing you will do is, of course, simplify. So you will have 2v minus 2/3 plus u plus 5/3 minus 1 dv plus, okay, another one here, you have v minus 1/3 minus u minus 5/3 plus 2 dy. Okay, somebody wrote in the chat box. Oh, okay. Thank you. It's du, correct. Thank you. So I forgot that our du, it should be du, not dy. Okay. Sige. Thank you for that. So we have this, then we're going to simplify our coefficients. You have 2b plus u. We'll copy it at the next. Okay, that's it. You have 2b plus u. I copied the variables. And the next thing we do is we subtract 2/3 from 5/3. So that would be 3/3 or 1 minus 1. So that would be 0. Okay, so that leaves us with dv na lang. Please check my user calculators there and check my addition and subtraction. Okay, next. In here, we have v minus u. So notice I started with the variables because I need to combine the constants. So I have minus 1/3 minus 5/3. So that would be minus 6/3, right? Or that would be minus 6/3. That would be minus 2. Plus 2, that would be 0. Okay, that's it. du equal to 0. Now, what have you noticed with the dE that we have here? What is this dE now? Anybody? This dE is, we have discussed this already. What kind of dE is this? So we copied the terms that has the variable, then we combine the constant. Minus 2/3 plus 5/3 is positive 3/3, or that's plus 1 minus 1, that's 0. Then we copy the v minus u. We have done it there. Then we simplify the constants. Combine negative 1/3 minus 5/3. It's negative 6/3, or that's negative 2 plus 2, that's 0. So this is our dE now. What kind of dE is this? Joshua, what kind of dE is this?
Miss,
Yeah.
nang
What kind of dE is that?
pwede ko siya, Miss, ma-homogeneous, Miss, pero at the same time, may pwede ko man siya ma-linear, guro, if ma-DVD ko siya. Ay, hindi siya ma-linear, Miss.
Hindi. So it is homogeneous.
Homogeneous, Miss.
Okay, homogeneous. So this is homogeneous. So you know how to use the procedure for homogeneous dE. The substitution equation is y is equal to vx. But since you already have the v variable here, you can use any other letter aside from the vx. So in this case, we can have y is sorry, wait, what happened there? So in this case, we'll have y is equal to ax. Okay, we cannot use v because we have there. And we cannot use y and x because we have v and u. So we'll change the y to v and u. But this is homogeneous. So this is v and this is u. Okay? So your original substitution equation, which is y equal to vx, you change the y and x to v and u, and you change the v to a. Okay? So we now differentiate this. So dv is equal to a du plus u dA. Then you go back here and substitute. So this is quite a long procedure, but that's how we solve coefficient linear into variables. Okay, now for the v here, you change that to au. So 2au plus u, and the dv will be changed to this. A du plus u dA. Plus another v there, which is au minus u, and the du is the du, 0. Okay, Then we distribute or we check whether we can cancel common factors in here without having to do expansion to save us time. You see a u and a u here, which could be factored out. So I'll just get it from there. It's just like you have factored it out because I have a u and a u here. So it's just like I've divided the entire dE by that u. That way we will not have to bring it again or have it carried out in all our subsequent lines in solution. So we'll have now 2a plus 1 a du plus u dA. Plus, you have here a minus 1. Then we use the FOIL method, algebra. So this one multiplied here and here. Okay, so in that case, you will have now 2a plus 1 multiplied by this a du plus another that one 2a plus 1 multiplied by u dA plus the quantity a minus 1. Okay, then what have you noticed? You have two du's. Of course, you need to combine. So you have this du here and this du here. So you combine their coefficients. So I have a 2a squared here and there's no a squared here. So I'll write it as 2a squared. Then I have an a and I have an a. So that would be 2a, right? A and another a. So that would be 2a. And I have here minus 1. Okay, D. And I have in the other side 2a plus 1 times u dA equal to 0. Now the dE is now, what have you noticed with the dE? The dE is now, check, separable. Okay, that's the usual case, correct, Jabel and Joshua? So from homogeneous, we normally convert it to separable. So this is separable. We can divide in a manner that way I'll be able to get rid of the u in here. So I'll divide by u and I'll get rid of this entire expression in this side. So 2a squared plus 2a minus 1. Okay. So on the next page, we have a du over u. So this term will be divided by u and this 2a plus 1 dA will be divided by this. Okay, 2a plus 1 dA for the other one. And you have 2a squared plus 2a. Okay, we check 2a squared plus 2a minus 1. Minus 1 dA. Let's see. The rest is now calculus. This is an ln of u. Okay. If this is our u, the denominator is our u, the du of that is 4a plus 2. So we just need to multiply the numerator by 2 because that will make it 4a plus 2. And I'll place here 1/2 to make it an ln. So I'll have 1/2 ln of 2a squared plus 2a minus 1. Correct? This is du over u is an ln of u. So the derivative of this is 4a plus 2. We only have 2a plus 1 here. So we multiply it by 2, we place 1/2 outside. Then we'll have here the, since I have ln's here class, I have mentioned it already to you, you can place your c as an ln of c. That way it's easy to simplify. Okay? Now I'll simplify ln. So this is u added to this. So that's multiplication, right? So you can have u times the square root. Why do you say square root? Because this 1/2 is the exponent of the argument of the ln here. So 2a squared plus 2a minus 1 equal to ln of c. That makes you get rid of the ln in both sides by erasing the entire equation, making it as the exponent of the e. So you have u square root of 2a squared plus 2a minus 1 equal to c. Okay? Now, but we don't have u and a in our original DE. So what is u or a? Rather, what is a? Rather, because in here, you have u and a. So what is a? A from here, yeah, write it here. A is equal to b over u. Wait, Kasha, give me a few minutes. Okay, so you have that now, class. Let's see. B over U for the A. So you go back here. So I'll copy it in black so you will see. A is B over U. So you'll have 2 times B over U squared plus 2 times B over U minus 1 equal to C. So there's a need for us to simplify the thing. Instead of the radical sign, we will have U square root of, make one big square root here. So you'll have 2v squared over u squared. Okay, something wrong with my pen. Okay, you have that. Then in here, you have 2v over u. Then we have the minus 1. To make this even simpler, we can combine it into one fraction. I'll just have it here, the c. This is c. So you have u square root of. So if we'll have u squared as our least common denominator, so you have 2v squared plus 2vu minus u squared. Okay, making u squared as the denominator, LCD. So 2vu minus u squared. Now, if you take the square root of this u squared in the denominator, that would be u, right? So then you can cancel this u and this 1. So what is left? Because if you take the square root of u squared, that would be u. What is left is just the square root. So you only have one long thing. 2v squared plus 2vu minus u squared equal to c. Now you can square both sides. That way you don't have the square root sign. So you have 2v squared plus 2vu minus u squared. It's still equal to another arbitrary constant, let's say an a. Because c squared is another arbitrary constant a. Okay, we're almost done, but this v and this u are not the original variables that we have. So we go back to this original equation. See this? So I'll use another color, make it orange, yellow, so green for Lausanne. Oh, that's it. So the v from in here, v is equal to x plus 1/3. The u is equal to y minus 5/3. So the v and the u that you have there should be changed by this. Because our original DE does not have the v and the u. but the other we have the x and the y. So 1/3 for the x and negative 5/3 for the y. So we have here for this one, so 2v squared will now change it to 2. Our v is x plus 1/3 squared. Then you have 2vu plus 2x plus 1/3 for the v, for the uy minus 5/3. I hope you will recall it. It's here. B is x plus 1/3, u is y minus 5/3. So we place it in here. I, then what do we have there? 2vu, 2v squared plus 2vu minus u squared. So minus y minus 5/3 squared equal to c. Now this is your solution to that first order differential equations with constant coefficients. It's really a long process, class, especially if the coefficients are that of a line like this, are that of a line which has a point of intersection. It's really long. From this form, you convert it to homogeneous. So we have converted to, where is the homogeneous TE? This is the homogeneous TE, and everybody knows that if it is homogeneous TE, the process is really long in converting it to separable. So now, from there, homogeneous, we converted it to separable DE. In this case, now it's separable DE. We have separated, actually your separable DE is in here. We divided by this so that we can integrate. Now, after you have your answers, you have 2 back substitutions, one for the homogeneous substitution and one for the original DE, which is this, for coefficient linear and true variables. Now, do you have any questions? This one is long.
Yes.
That, yes.
Question, miss. Pwede, may iba nga method, miss, nga pag-solve sa equation kagina compared sa subong?
Wala. Amo lang gina siya, Josh.
Okay, miss.
Wala gid. Sorry to say, wala. Amo na nga may ara kita, may ara kita type na first order DE nga amo ni kay para ma-solve siya. Or else hindi siya ma-solve. Okay. What about the others? Do you have any questions? If you wish to take a screenshot of the solution, although this is recorded, you may do so. So this is the first page. This is the second page. This is the third page. Fourth page. Fifth page. And the sixth page.
Miss, pwede ko ka-ask. Sa fifth page bla, miss. Paano siya miss? U squared na bla bilin? Sa 2v squared all over u squared plus 2v all over u minus 1.
Algebra. You combine these terms here. You have 2 fractions and 1 constant into 1 fraction using the LCD. So your LCD is u squared.
Sige, miss.
No more questions? The next type for coefficient linear in 2 variables is for coefficients resembling the equation of parallel lines. This for example, this one is for a non-parallel line or non-parallel lines, meaning they will really have a point of intersection. So if you have parallel lines, in the case of the second example I'm giving you, the process is similar to substitution. Okay, so let me give you a second example. That is if you don't have any more questions here in the first example. This one is short. the ones with the coefficients resembling that of a parallel line. You have any questions here in the first example? Okay, now. So I will create here a second DE in which the coefficients are resembling that of a line, a parallel line. So let's say I have x plus y plus 2 dx plus 2x plus 2y minus 5 dy equal to 0. Just like what we did in the first example, you will write down separately the two coefficients. So these are the two linear coefficients. So we'll separately write them down. X plus y plus 2 equal to 0. And you have 2x plus 2y minus 5 equal to 0. What have you noticed? What have you noticed with the two linear equations? Bakit ka mo may
Miss,
ano?
kung i-try mo mas use ang process of elimination, may eliminate ang both x and y variable. Therefore, hindi, wala point of intersection.
Correct. Very good. Very good. So if you look at the coefficients of the variable x and y, of variables x and y here, they are not the same, but they are of the same multiple. So what happened here is that your x plus y here was just simply multiplied by 2 to give you a 2x plus 2y. Whenever you have this case, not looking into or you're not interested with the constant that goes with these two variables, you have a case of parallel lines. So you have a case of parallel lines if the coefficients of the two variables are exactly the same, like you can also have your x plus y minus 5. So they are said to be parallel, or one is a multiple of another, meaning you just multiply the coefficients of the first one with a certain constant and you'll get the coefficient of the second line. So in this case, we simply multiplied x plus y by 2 to give it a 2x plus 2y. Okay, in that case, you don't find the point of intersection because, as your classmate has said in the chat box, they will all get canceled out. You'll not get anything. You'll not be able to solve for the point of intersection. Primarily, we go back to what you have learned in analytic geometry. Whenever lines are parallel, they will never meet. And as such, they will never have a point of intersection. Okay, so in that case, what you're going to do is use the method of substitution, just like the way we have done it before. There's something similar to these two sets of variables in here. One is only multiplied by 2 to get the second. What you're going to do, we'll have a substitution equation like let's say z equal to x plus y. Right? Then you use this equation. You differentiate rather this equation, so you have dz equal to dx plus dy. And you decide which of the x or the y variable you keep. So in this case, we decide to keep the y. So dx is expressed in terms of dz and dy. So dz minus dy. dz minus dy. Now this one and this will be used in here in the original DE. So I'll go back to the original DE. So you change x plus y to z. So you have z plus 2. So this is really substitution that we're doing. And dx would be this one, dz minus dy. And you have here plus. So since this is twice of this, you just multiply it by 2. So 2z. 2z. Because if you multiply z by 2, you'll have 2x plus 2y. Then you have minus 5. Then you have dy equal to 0. Okay? Then you use the FOIL method to simplify, just like in substitution, and check whether you have separation of variables or any, or linear DE or any of the other forms. So we'll do that in here. So you have x plus 2 multiplied to dz So, okay. Z plus 2. It's not x plus 2. I said x plus 2. Z plus 2 dz. You use the FOIL method, then you'll have this one, z plus 2 minus dy. Notice that I didn't really multiply it piece by piece, but I multiply this as a whole, and you have there 2z minus 5. So you have two terms that has the dy, this one and this one, so you can combine. So you have z plus 2 dz plus, I'd like to start here, it's positive 2z minus z, so that would be z. I have minus 5 minus 2, that would be minus 7. dy equal to 0. Okay, so z minus 7 dy equal to 0. This is a parable, right? You just divide by z minus 7. So you'll have a z plus 2 divided by z minus 7 dz plus dy. And we've discussed this already in the method of substitution, how to deal with this particular integral. So since the degree of the numerator and the denominator are equal, you have to use long division. So z plus 2 divided by z minus 7. You have a 1 and you have a z minus 7. And you have here a 9 because you're going to subtract. Okay, so this is your remainder. So you have a dz for your first term. And for your second term, you have the 9. That's your remainder. Plus 9. And you have the z minus 7 as the denominator. So this is dz minus z minus 7. And you have dy. Okay? Z minus 7 and you have dy. Then the rest is just easy. You have a z plus ln of z minus 7. So of course you have the 9 there. You have the y equal to c. So you have 9 ln of z minus 7 plus z plus y equal to c. But what is z? Because we don't have the z variable. So the z variable, is x plus y. Okay? You go back here and substitute x plus y. So you have 9 ln of x plus y minus 7. And you have plus x plus y plus y. So we can combine. So 9 ln of x plus y minus 7 plus x plus 2y. So this is already the solution of this DE, which has coefficients linear also in two variables. However, I said the linear equations are, or the equations of the lines here are for parallel lines. So we cannot have the point of intersection. So you recall the process of substitution. And we have discussed this in part last week under method of substitution. Okay? Now, any question? So this is your first page for example 2. This is your second page. And this is the last page. Okay, this is the 9th topic under first order differential equations. As to types of first order DE, we have separable, homogeneous, exact, linear, Bernoulli, and this is the 6th. Coefficient linear in two variables. The other topics that we have discussed are how to make the inexact DE linear using the integrating factor. That's one topic. Or using the table of exact differentials. That's the method of inspection. And we also use the method of substitution. So that makes all 9 topics under first order differential equations. Do you have any questions?
Miss, what if equal ang duha ka equation, Miss? Exactly. Duha, meaning tanan-tanan nag-intersect sila duha.
Wait lang. What do you mean x plus y plus 2 and x plus y plus 2 here?
Doka mo na, Miss. Hindi na namin sa muna. Kaya syempre pwede mo na sa matest for like other methods na sa previous discussion to, Miss. Kaya either equal mo sa duha. Or may ginabot sa
If you'll have x plus y plus 2 and x plus y plus 2, kung divide mo, wala na siya coefficient eh. dx and dy na lang bilhin.
kaya, kaglips.
Right? So if they have the same coefficients, you just divide it so their life is even simpler because you just divide and you just left with dx and dy to integrate. Right?
Miss, ang sa number 2, Miss, hindi ko na siya inexact may exactness.
Josh, you can always use a method that you're comfortable in as long as it's used correctly. So I'm not limiting you to the method that is written here, but how it is being discussed in the book is using substitution. But if you
Yes, thank
think
you.
that you can solve this using finding the integrating factor, fine. But usually I discourage using that particular technique. I suggest that is to be used last because of the process of trial and error. So it will take you time to find the answer. Where in this one, you really have a procedure to follow and you will really arrive at the answer. The problem with the method of substitution, no, not the problem with substitution. The problem with making an inexact DE exact is the process of choosing which of the methods, the 2 methods discussed, will arrive at the correct integrating factor. So what if you already finished finding f of x? It's not possible. G of y, it's not possible. So you're going to use inspection. If you're going to use inspection, let's face it, class, the method of inspection are for those who are skilled in algebra. You have to be good in regrouping of terms and you have to have a keen eye on how you're going to regroup your terms in such a way that you'll be able to come up with an exact differential that you see in the table that was given to you. If it's not seen there, then you will have a big problem. Masakit naman ulo nyo. Ano na ni karon pag sugit, taklogit, hindi pwede. Hindi ko kabalo mag-inspection. So I still would like to go with the method that is presented here for number 2. That way, you will have a sense of direction unless you are the type who would love to be challenged. Okay lang sa ako na challenge ko basta kabalo ko nga pwede galing. Okay? So there's no clear-cut procedure here on how to convert one DE into another, or a particular DE can only be solved by one particular method. There could be several, but it's still up to the comfort zone of the user, and it's still up to the skill of the user of that particular technique. Okay, I have here somebody. Miss, pwede makapa-consult, Miss? You can consult to me during my consultation hours. It's also posted in Canvas. But of course, if you want face-to-face consultation, it has to be on a week wherein we're having face-to-face. If not, it has to be on a time wherein I don't have class. Anyway, it's there in the consultation period. Just let me know when will that be, whether in Zoom or in face-to-face. Especially if it's Zoom, because though I have my schedule of classes in Zoom, my regular classes, but we do not know if other students have also been asking for a consultation. So you have to set with me first the schedule. Any question? Okay. Okay, any questions? So
Pwede ako balik sa number 1, Miss.
Which part?
Dira, miss. Stop, miss. Bali, kagina, miss. Pag foil mo din, miss, sa 2a plus 1 multiplied by ADU plus UDA, miss. Amugin, paano siya, miss, come out sa A multiplied by 2a plus 1 DU plus 2a plus 1 UDA, miss.
Algebra.
Okay, miss. Sige, miss. Salamat.
Some more questions? Okay, sige. Okay, here on the inbox. Okay.
Bye, Miss Arlene.
Any questions? Sige, I'll just take a screenshot. I'll stop sharing here.